We want to find the pH of a 0.010 molar HNO2 solution. So the keywords here are pH and then a concentration. So you guessed it, this is a Rice method, so I need to do my reaction first. Well, the only thing I'm provided with is the HNO2, so I'm going to write down that first. We've got HNO2. We know that when we're dealing with these acids that these are always in a solution of water, so you get H2O liquid. This is at equilibrium, so we're going to change the water. We're going to add a hydrogen. That becomes the hydronium ion. And then we lose a hydrogen from the acid and we just get the NO2 minus ion. Okay, so far so good. So then I've got my I. So my initial concentration, I'm only provided of the acid, so this is 0.010. That's a liquid, it doesn't matter. I've got 0 and I've got 0. So then what's the change? Well, I've got to get rid of some of this, so that's a minus x. This is a plus x, and this is a plus x. And then ultimately, we need to find equilibrium. So we add straight down, so we get 0.010 minus x, and I get x, and I get x. So that's the hard part, right? I hope it is. So now I need to do the Ka value in order to solve for the hydronium concentration. So I know that Ka equals the products over the reactants. So I'm going to write that out. Now make sure you either have your table or you already know what the Ka value is. So when I get that from the table in my book, I got 4.6 times 10 to the minus fourth. And now I'm going to put my variables. So I've got an x and an x, so I've got x squared over 0.010 minus x. Now, of course, you know the question is, can we do the approximation? Well, we're going to go ahead and work through it as if we did the approximation and see what happens. So if I do the approximation, this would just become x squared over 0.010. And I would cross multiply, so that would be 4.6 times 10 to the minus fourth times 0.010 equals x squared, and I'd have to take the square root of both sides. And when I do that, I get 2.144761 times 10 to the minus third equals x. And then when I plug that in, I would take 2.144, and I just used a couple of them, it's not going to make a big difference, over the actual initial concentration times 100. Oh man, I got 21.4%. That means I can't approximate it. So what we're going to do is we're going to go back up here, and I'm going to start again at this step up here. So since I can't approximate, this is what we originally started with. So I'm going to have to cross multiply equals x squared, and then I'm going to have to set it equal to 0. So I want you to do that aspect first and get all the way up to where you have to find a, b, and c for the quadratic equation. So hopefully this is what you got when it's set equal to 0. So when I do this, I know now that a is going to be 1, b is going to equal to 4.6 times 10 to the minus fourth, and then c is going to equal to negative 4.6 times 10 to the minus sixth. So what you're going to use is the quadratic formula. So recall that is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. So what I want you to do is I want you to go ahead and plug everything in, solve it, and then come back and check your answer. So as chance would have it, I ran out of room, but here's where I plugged everything in, and then I simplified it in the next step. So I noticed the first one is to the minus 4, and this one is a minus 3. So the first one is smaller than the second one. So if I do a negative plus a positive, it's going to be a positive. And if I do a negative minus a negative, it's still going to be a negative. So that means that the minus sign right here, we're not going to do that part. So instead, I'm just going to take the first number plus the second number divided by 2, and when I do that, I get 1.927058 times 10 to the minus 3 molar. But I didn't care about the hydronium, right? I actually ultimately want the pH. So I just take the pH is equal to the negative log of the hydronium concentration, which is what we just found above. So that's this number right here. So when I plug that in, remember I want 2 decimal places after for significant. So I get 2.72.